A warm greetings to one and all. Myself, Dr.g. Padmapriya, Assistant Professor, Department of Computing Technologies. Today, let's learn about IO operations in C++. The topics to be covered today are Introduction to IO operations, Hierarchy of console stream classes, IO header files, Formatted IO streams, Unformatted IO streams, and example program for these topics. As a part of introduction, let's start with streams. Normally in C++, IO operations are mainly based on streams, which are the sequence of bytes flowing in and out of the programs. In input-out operations, the data bytes flows from an input source such as keyboard, file, network, or any other program into C++ program via input stream. In output operations, the data bytes flows from the program to an output stream such as console, file, network, or any other program via output stream. The streams acts as an intermediate between the programmers and the actual IO devices in such a way that it frees the programmers from handling the actual devices so as to achieve device independent IO operations. The hierarchy of console stream classes is depicted in this picture here. The topmost parent class is iOS class. That is input output stream class. It consists of basic facilities that are used by all the input and output classes. It has three child classes, namely iStream, stream buffer, and oStream. iStream is used to declare the input functions such as get, getLine, and read. Stream buffers provides an interface to the physical devices through the buffers. OStream declare the output functions such as put and write. And IOStream is a class, child class, where it inherits the properties of iStream and OStream through multiple inheritance, and thus it contains all the input and output functions. iStream, IOStream, and OStream has the child class name underscore with assign respectively. This with assign class, a child class is used to provide extra functionality for assignment operations. Then let's see about IO header files. These are the following header files which are important to C++ program. IO stream header file. This files define cin, cout, cerr, clog objects. Where cin represents the standard input stream, cout represents a standard output stream, cerr represents unbuffered standard error stream, a clog object represents the buffered standard error stream. IO manip header file. This file declares the services useful for performing formatted IO with so-called parameterized stream manipulators such as setW and setPrecisions are used here as functions. Fstream header file. This file declares services for user-controlled file processing. We can see an example program where we have included the IOStream header file using include statement, #include. It is also called as preprocessor directive. Using namespace std, this statement includes all the identifiers of C++ standard library that are defined in namespace called std, where this statement brings all the identifiers to the current scope. Next, we have declared the main function and we have declared the variable named name of the type character array with size 50. Using cout object, we have displayed the information to the user as please enter your name. Using cin object, we have got the value from the user for the variable name. Using cout, your name is statement is printed and the value for the variable name is also printed to the user. And character string array is being declared with the value unable to read. Using CRR and CLOG statement object, we have declared the error message to the users. So this is what the output of this program. We have got the input from the user using cin statement, and using cout statement we have displayed the values to the user, and using cerr and clog object we have declared the error message to the users. The next topic is unformatted IO operation. Extraction operator is overloaded in iStream class and insertion operation is overloaded in OStream class. Class iStream and OStream define two member functions, namely get and put. We can read and display a line of text more efficiently using line-oriented IO functions with getLine and write. We can see an example programs here. So we have included IOStream header file and we have included the directive namespace std, and in main function I have declared the variable a of type character, and I have got the input value from the user using the object cin dot get function for the variable a, and I have displayed the value of the variable a to the user using object cout dot function put. So this is what the output of the program. I have got the value for the variable a using cin.get from the user, and I have returned the value to the user using cout.put function. In next example, here I have got the input from the user using cin.getLine. Cin is object, we all know, and getLine is a function. So it has two arguments, namely variable comma size. So here the variable which I have used is name and size is 20. And I have displayed the value of name of size 20 to the user using cout.write. So this is what the output. So we got the input using getLine and we have displayed the output using cout.write. Next, we are going to see about formatted input and output operations. The main functions which are included here is width of function, precision function, and fill function. So width function is mainly used to specify the field size and number of columns to display the value. The usage of width is cout.width of 6, which means I have given the column size as 6. The value which I have to print is or to show to the user is 1239. So since it is less than 6, it has been displayed as such in 1239. Precision. This precision function used to specify the number of digits to be displayed after the decimal point of the float value. Usages cout.precision of 3. So I have given the precision value as 3, which means the digit to be displayed after the decimal point is 3 digits. So let me give the cout statement. Cout object has the value 1.234567. Since after decimal point I required only 3 digits, the value printed as 1.234. Remaining 567 is truncated. Fill of function specifies a character to fill the unused portion of the field. So see here how we can use it. Cout.fill. This is what the character to be filled in unused space. The width I have specified here is 6 and the value which to be displayed is 1239. It has been given in cout statement. So the total length here it is 6. So I have used 4 digits here 1239, and remaining 2 unused space is filled with hash symbol or hash character. Let's learn about formatting with flags using setf function. The syntax for setf function is cout.setf argument 1 comma argument 2. The argument 1 represents the flag field and argument 2 represents the bit field. So whatever the functions we require in setf, we should give argument 1 and argument 2. And few function may not have argument 2. We can see all those things. So first one is to justify our output. So our output can be left justified, right justified, or it can be internally justified output. So for left justifying output, the flag should be represented as left. Since the function left is in the scope iOS class, we have defined it as iOS scope resolution left. And for right justification, iOS scope resolution right. And for internal justification, we have given iOS scope resolution internal. The argument 2, which represents a bit field. So for formatting or for justifying the output, we are using iOS scope resolution adjust field. So for all the three types, left, right, and internal, we are using adjust field as bit field for justifying the output. To represent the floating point numbers, we have two notations, namely scientific and fixed point notation. To specify the scientific notation, the flag field is specified as iOS scope resolution scientific and the bit field is iOS scope resolution float field. Similarly, for floating point notation, the flag field is IOS scope resolution fixed and bit field is IOS scope resolution float field. In order to specify the number in number system, any of the number system, namely decimal, octal or hexadecimal, the base value can be specified using DEC, OCT, HEX functions which is available in iOS class, and the bit field should be given as base field. And to show the base value when displaying the integers, we are using the flag as iOS scope resolution show base, and the bit field is not applicable here. To show the decimal point when displaying the floating point numbers, we use the flag field. iOS scope resolution show point function. Here also the bit field is not applicable. And to show positive sign when displaying the positive integers, we are using iOS scope resolution show POS. And here also the bit field is not applicable. And to display the letters in uppercase, we are using the flag field as iOS scope resolution uppercase, and the bit field is not applicable here. Now let's see an example program here. We have included IO stream header file, and we have included the namespace std for including all the way identifiers in the C++ standard library into our scope. And in main function, the first statement is cout.setf. Setf is a function, set flag function, where we have used argument 1, argument 2 as two arguments for the setf function. So here iOS scope resolution HEX, iOS scope resolution base field. So the HEX function is available in the class iOS. So we are giving the scope resolution operator iOS scope resolution HEX. And base field function is also available in the class scope iOS. So iOS scope resolution base field. Now we have set the base field as hexadecimal. After setting the base field, we have to display the base field. So for that, I am using the function cout.setf iOS scope resolution show base. So this displays the base value. The next statement is cout.setf. So here I have used iOS scope resolution uppercase. So since I have used uppercase, the base value will be printed in uppercase, will be displayed in uppercase. cout.setf here iOS scope resolution right, iOS scope resolution adjust field. I have adjust the field using right justification. So the output value will be right justified. And cout dot width of 6. The output value which to be given to the user is of size or width 6 digits. And cout dot fill hash character. This hash character is used to fill the unused space. Since I have given the size as 6, if the values to be printed in the output is 6, the 6 will be printed. If any unused space is there, then it will be filled with hash. So I have given the next statement as cout 100. Now let's see the output, how it has been displayed. The 100 is represented in hexadecimal format. So 100 is converted to 64. Since I have given this flag for showing the base value, so the base value 0x, which represents the hexadecimal number system, is being printed after the 64. Since I have given uppercase, the x is being displayed in capital letter. And the justification is done in right side using adjust field. So the value 0x64 is justified in right side. The width I have specified is 6. So total 1, 2, 3, 4, 5, 6 digits can be occupied, but actually 0x6 4 digit is being occupied, and the remaining 2 field is filled with has character. So this is what the output of our program. Hope you all understood. Thank you all.